Hey, hello, this is Bob Jackson, here with SC 201. This is week 7 for the 8-week online course. And this is chapter 10. And in chapter 10, all I'm going to cover in it is going to be on acids and bases. There is also water solution chemistry in that chapter. And we're just going to do the acids and bases part of that chapter. Because I think it's just most applicable and is good content to teach. And there's some fun stuff to do with students with acid-base chemistry. Okay, so anyway, the main concepts that we're going to cover are properties of acids and what acids are, of course, and then properties of bases and what bases are. And we will talk about some common acids that you find at home and some common acids that are used in industry and other places because they are used all over the place. Some acids are actually really dangerous. Others aren't so bad. And the same thing with bases. We'll talk about some bases that are commonly used at home and some bases that are used in industry. Okay. Many people are familiar with the term acids, but a lot of people don't realize or know or understand what bases are. Just not familiar with it. They are pretty common, and you have a lot of things in the home and in industry that are actually bases. Another term used for bases is what you call alkaline. Okay, anytime you have an alkaline material, it is a base. Okay, we'll talk about the pH scale and then acid-base indicators. And they're what can make chemistry fun for kids, playing around with some acid-base indicators. Okay, so let's move through this. Okay, maybe, there we go. Okay, we'll first start with acids, and here's some definitions and some terms behind acids and actually properties of acids as well. So if we want to start out to define acids, we'd say acids are solutions or substances that produce hydrogen ions in solution. Okay, you can also hear it as hydronium ions. Okay, so don't be confused if you see or read it in a book that it says produces hydronium ions, which is H3O, and that's where actually a hydrogen ion piggybacks on a water molecule. So water molecule is H2O. If you put a hydrogen ion on it, it'd be H3O, and H3O is what we call hydronium ions. Okay, so acid, you'd say produce hydrogen ions to keep it simple in solution. Okay, or you can say they produce hydronium ions in solution, because that's actually what they do, because those hydrogen ions ride on water molecules and make them H3Os. Okay, acids have pH levels between 0 and 7, they'll usually say. I always put it as 0 and 6.999. So if it has a pH of 6.9999, whatever, it is barely acid. Okay, because 7.0 is neutral. Okay, it is neither acid nor base. Okay, then the next point I have there is many of our acids will react with active metals. Okay, and as you go into chemistry, you learn what some active metals are, like zinc and magnesium and sodium and calcium, that are pretty reactive metals. Okay, if you take those metals and put them in an acid like hydrochloric acid, which the ones I have in class will play around with, it'll quickly or pretty quickly make hydrogen gas. And hydrogen gas is explosive. You can ignite it. Okay, it can be dangerous. Okay, and that's why with a car battery that has acid in it, when you jump start a car, you should never ever have your face in there when as you're actively jumping that car, because if the battery has a buildup of hydrogen gas around it, it can explode. Those things do happen once in a while. Okay, acids turn litmus paper red. Litmus paper has an indicator in it, a substance that will turn colors at a given pH. Okay, so litmus paper will turn red or pink colored with acids. Okay, we always refer to it as red. It can usually be somewhere in the pink to red range. Okay, when you take and mix an acid with a base, we say we have a neutralization reaction occurring. So we say acids will neutralize bases when they react together. And when this reaction takes place, they form water and salt every time. Okay, anytime you have an acid-base reaction or a neutralization reaction, you will produce water and you will produce a salt. Okay, acids in foods, which there are some common acids in foods, will tend to give the food a sour taste. Okay, so moving on. Here's some common acids at home. Okay, just like I was saying, you got your car batteries up there. Here's a car battery. Well, it's not really a car battery. I guess that's a like an ATV battery. Okay, this is a car battery over here. But what they have inside them is sulfuric acid. Okay, really the most dangerous acid that we work and have around us. Okay, it can be extremely dangerous. You get it in your eyes, it can blind you. It's very rough on the skin. It is very reactive. It's very reactive with a lot of different materials. And it's even with mixing sulfuric acid with water can be extremely dangerous. Not that there's a reaction there, just a lot of heat energy is produced really, really quick, which can vaporize the water and blow all the sulfuric acid right in your face. That's what people don't realize. If you just take and dump sulfuric acid into water, which you should never ever do, you can blow everything apart right there. Okay, it is a very dangerous mistake to make in a lab. You always pour an acid into water. You don't do it the other way around, and you do it slowly. Okay, you do not pour water into an acid. Okay, some other common acids at home. We go from any of your sodas, any of your Coca-Cola, Pepsi, Dr. Pepper, any of them go have acid content to them. Wine, vinegar. I think these are all vinegars here. Okay, whether it's white vinegar, red vinegar, any of the vinegars are acids. Okay, they aren't nearly as strong as sulfuric or hydrochloric, but it is still an acid. In your fruits, you got citric acid. In milk, you have lactic acid. Okay, aspirin is a acetylsalicylic acid. Okay, but then it's showing you over here just some sources of acids. Okay, all the way you see an ant here, or bees. Bees should be on here. You get a bee sting, it's formic acid that's causing the sting. Okay, but all your fruits and many vegetables have acids in them. Like in tomatoes, you have oxalic acid, citric acid in lemons and limes and oranges. Okay, and then apples, you have malic acid. Okay, so those are common acids at home. Okay, I don't know that you'd have elementary kids know these names, but you could have them know like apples and oranges and their fruits all have acids in them. Okay, you might get them to know citric acid because it's pretty common, and lactic acid in milk. Okay, and then here's some common acids used in industry. Okay, by far the most common one of all, sulfuric acid. It's used big time. I mean, there's all kinds of sulfuric acid that travels across the roads and on trains and everything else, and it's by far the most dangerous acid common acid that we work with. But then hydrochloric acid is used quite a bit. Okay, in labs, it's used the most in labs, like high school labs, college labs, so forth. That's probably used the most like that. But in industry, as far as I know, sulfuric acid is. Nitric acid's a big acid that's used in industry and for several different processes. But then you have like hydrobromic acid, hydroiodic acid, perchloric, and chloric acid. These are probably pretty common in industry above these two. Okay. But then you have several weak acids, which like oxalic acid and sulfuric, or not sulfuric, your sulfurous acid and phosphoric acid. Phosphoric acid is pretty common, okay, in industry. Benzoic acid is, acetic acid by far, and then formic acid, which formic acid, like I say, is, it's used in several industrial processes, but it's in bee stings and in ants. Okay, you find it naturally in ants. Okay, so that's common acids. Okay, both in home and then in industry on this page. Okay, here's some good videos that you can go to look at on this slides. If you go back and look at them, like this first one here, you'll see, I'm not going to play it all the way, I'll just kind of show you. You drop metals down into hydrochloric acid, you start seeing those bubbles. That's hydrogen gas very quickly coming off there, and it's very ignitable. It's very flammable. Okay, explosive if you collect it, and you can actually blow it up. Okay, so I'll just kind of speed it through there. You'll see the metal looks like it disappears while it's reacting to form a. Here's going to ignite it. Hear a little pop. A lot of times, if you'd shut the lights off, you would have seen the flame come off of it. Okay, here's magnesium. Now, magnesium is really reactive. Okay, or because a piece drop down in there, you'll see it going really quick. Now, if you felt the bottom of that test tube, it'd be really hot. Okay, it gets hot pretty quick. Okay, and you can go back and you can look at these. Okay, it's not bad. Then down here on this one is where we're seeing acid-base reactions. We're taking the acid and reacting with the base. It's actually called a neutralization reaction, and they're fun to play with in the lab. Where he has indicators in there and is getting ready to react these two. Okay, pours the one into the other, and then whoa, there you go. Okay, that was a neutralization reaction that just took place and formed salt and water that's in there now. It's not what was in there. It was hydrochloric acid and sodium hydroxide being a base. Okay, but you can go back and you can look at those. Okay, on to the next slide. Okay, here we talk about bases. Okay, bases, contrary to acids, produce hydroxide ions in solution. And what you can realize and know is when we react acids and bases together, they always form water. Acids are hydrogen, bases are OH. HOH is H2O. Okay, that's the reason. They neutralize each other. Okay, they'll form that H2O, HOH. Okay, so bases produce hydroxide ions in aqueous solution. That's a sand and water solution. They have a pH level between 7.01 and 14. Okay, they're on the upper end of the pH scale. They have very caustic action on plant and animal tissues, which means most people would probably call it a burn, but it'll really mess up your skin. Okay, and on animals, you can tell animals if they've got into some hydroxides, some bases, you can tell that it's worked on their skin and even on their mouths and so forth. Okay, but they can be pretty rough, and most will hydroxides will kill plants. You'll see the plants look like they're burnt by the chemical that hit them. They'll be all shriveled up and crinkled up. Okay, bases will turn litmus paper blue. Again, litmus paper has an indicator dye in it that was dried in it. It will turn different colors at different pHs. And bases tend to turn blue, and some of them will turn it green, actually. Okay, so your main color is blue, but you also realize that bases also look green at times with the pH paper. So you can say green to blue. Okay, they will, just like acids will neutralize bases, bases will neutralize acids. When you react them together, they always form water and salt. And that's what was seen with the one video just before this, an acid-base reaction. Okay, if you happen to get a base on you, like if you get an acid on you, you can't tell you get an acid on you until it starts burning because it's going to feel like water. But if you get a base on you, it feels oily. Okay, you can tell really, really quick typically if you get a base on you. It feels like you got oil on your skin. If you're working in a lab with acids and bases, you need to go wash your hands real quick because it can end up having a caustic action on your skin, which you'll see it as a burn. It takes a little bit of time, but it'll happen. Okay, and then bases in foods, naturally in foods, give foods a bitter taste. Okay, acids are sour, bases are bitter. Okay, common bases we find at home are a lot of our cleaners. Okay, you've got like Windex window cleaners and so forth to what you're cleaning the toilet bowls out with. Okay, several of these are scrubbing bubbles there. These are all bases. If you see on them that they got hydroxides in them, they're bases. There are some cleaners that are acidic, but an awful lot of them are bases. Okay, antacid tablets, Tums, and so forth, they're all bases because you got acid in your stomach. That's what's going to settle it down is a neutralization reaction with the base. Okay, all your batteries, your dry cell batteries, AA batteries, 9-volt batteries, C and D batteries, they're all alkaline batteries. Alkaline is another term for base. Okay, so these contain bases. Okay, and you see the caustic action right there. Okay, corroding that metal actually. Okay, and here's some more cleaners here. In cooking, your bicarbonate, your baking soda, it's a base. Okay, bicarbonate of soda. I don't know. Most of them would say baking soda on the box. Okay, those are all bases. Okay, common bases used in industry. Probably the most used is sodium hydroxide and magnesium hydroxide, and maybe calcium hydroxide right in there close. Sodium hydroxide, barium, sodium hydroxide, magnesium hydroxide, calcium hydroxide is probably some of the most used. But these others, like lithium batteries and so forth, lithium hydroxide, okay, barium hydroxide, zinc hydroxide is halfway common out there. Okay, they use it for protecting steel and making galvanized metal. Okay, but these are all of them you'll see are hydroxides, and they're all metal hydroxides. Okay, so like sodium hydroxide, lithium hydroxide, barium hydroxide. Okay, they're common bases. Okay, and I have uses of them over here. Okay, the pH scale. This is one of the most important things to learn in this chapter. Okay, on the scale goes from 1 to 14. There is a reason for that. I don't know that you'll go into that for elementary students, but it's because the ion product constant of water is 1 times 10 to the minus 14. Okay, the ion product constant of water is 1 times 10 to the minus 14. And that makes that scale 1 to 14. Okay, your acid pHs go from actually 0, it doesn't show on here, to 7, which is really to 6.999 because 7 is neutral. And your bases go from 7.01 to 14. Okay, now then, this is colored up like it was indicators, okay, but this will change with different indicators. You should use the coloration, so you can't really memorize the colors that go with them, just kind of where things are on the pH scale. Here are some common household stuff where you'd see them on the pH scale range from stomach acid at pH of 1 up to coffee and milk and so forth, pH 5, 6, and which is pretty harmless to us. Okay, to your baking soda and blood and so forth, closer to this, just above pH of 7. Okay, but once you get into some of your cleaners that you use at home, some of them are halfway dangerous, have them pH levels way up there around 13 or 14. Those can be pretty dangerous and toxic and cause burns and so forth. And that's why when some of those cleaners, you feel the burning of your eyes and so forth, they're even rough on your skin when you're using them. Well, it's because it gets such high pH levels. Okay, now the thing to know about the pH scale and to teach and get kids to understand is the pH scale is logarithmic, or it's a log scale, you call it. And what that means, put it in simple terms, there's 10 times difference between each level on a pH scale. Okay, so a pH of 1 is 10 times more acid than a pH of 2. A pH of 2 is 10 times more acid than a pH of 3. But if I take 2 levels difference, a pH of 1 is 100 times more acid than a pH of 3. A pH of 3 is 100 times more acid than a pH of 5. So that's when, if you have the pH of a lake or a stream drop from a pH of like 5.5, which can be halfway common around here, and it drops down in the 4 ranges, everything dies in it because all the living things, fish and microorganisms, can't live at those pHs because it's 10 times difference if I go down a whole pH level. And that's what acid rain's all about, and measuring that in water quality studies and so forth. Okay, so there's 10 times difference. If you go on this side, it goes the opposite. 14 is 10 times greater than 13. 13, 10 times greater than 12, and so forth. But if I go 2, if I compare 14 to a 12, 14 is 100 times more basic than a 12. I mean, that's it, right? Is 100 times more basic than a 12, okay? And that's huge, okay? That's between not really deadly and deadly, okay? When it comes to what you consume, like you can take eating baking soda and antacids and so forth at these pHs, but you couldn't take drinking this stuff up here, okay? It just can't happen. All right, so that's a key thing to get taught on the pH scale is logarithmic. There's 10 times between each level. So if you go 3 levels difference, that's 1,000 times difference. Okay, so it's huge. So if you go from a pH of 7 down to 4, that's 1,000 times different in pH concentration and acid concentration. A lot more problems going to be at pH of 4. Okay, our body's like pH of 7. That's where you see a whole lot of products and soaps and shampoos and so forth, where they'll say they're pH balanced. They're in these ranges. Okay, that's pH scale. Main thing to know. Okay, pH indicators. Okay, pH indicators are compounds that change color in solution at different pH levels. Okay, and there are several different ones. There's even a whole lot more than these. Okay, most common one I've used in lab is phenolphthalein. But you take thymol blue, methyl orange, bromphenol blue, Congo red. These are all extracts out of plants, and they will turn different colors at different pHs. Just like in the fall when the leaves change color around here, those colors are relative to the pH levels inside those leaves. Okay, and you can make them change. You can take a leaf and play around with it, put them in acids and base solutions. Okay, so indicators change color. So now then, that's where we use indicators now to be able to tell pHs easily. If you put a few drops of an indicator into a solution, you can tell quickly whether it is an acid or a base based on the color that it turns. Okay. So then that's what's going on here in this video. If you watch this one with Tyler Doerr, he will show you some about acid-base indicators. Now, I'm not going to play the whole thing. I'll let you play it. I'll just kind of take it through here. He's going to take and put that. Whoop, I went by too quick. Just force it in there. They change colors. Okay. Each one of those are different pHs. Okay. And he'll talk on to here. Bases are typically these colors, acids, these colors. It is pretty cool. And with, you can watch this and do this. This is a great demo to do in front of students. Okay. That's acid-base chemistry, and that next wrap. Hey, have a good day. This will be the last of the videos for for the online course. Okay. Thank you.